What's the percent increase? Percent markup. It's not going to be this.
It's going to be the opposite then.
Right.
Or what the other, it's going to be like 68.75.
So how would you do it? How much did it change by?
$5.
So the percent is change divided by original. It changed by $5, but what's the original? 11. Do you guys see that? Do you see that? Because now it's based on 11. That's what it was originally. So whatever markup I applied to 11 was based on 11. Here it was based on 16. Here it's based on 11. What is 5 divided by 11? 0.4 something.
4.5. 4.5.
I like it. 0.45 forever, which is 45.45 forever percent. So that's the weird thing about percentages. 10% does not equal 10%. What do I mean? Stay with me for a second. I don't think I told you this story, did I?
No.
If I was making, let's pretend like I'm making $10 an hour, which used to be really good, but now it's sort of normal almost. If I'm making $10 an hour, and they decrease my pay by 10%, just out of nowhere, for no reason. Well, how much am I making now per hour? I was making $10 an hour. They decreased that by 10%. What's 10% of 10? 1. 11. So now decrease that. So now I'm making $9 an hour. I'm angry. I'm like, what the flip? What happened? What did I do? I got nothing. So I go to them. I complain. They say, oh, we're so sorry. We'll increase your pay by 10%. There you go. Right. Now I'm a math geek, so I'm still mad. Right. Some of you guys might be like, well, that sounds great. They're giving you back the 10% they took off. But what's 10% of 9? 0.9. So now I'm making $9.90, and some of you guys might realize dimes add up over time, right? 10 cents an hour adds up over time. Are you guys semi with me?
Yeah.
So 10% does not equal 10%. It depends on what it's of. That's why the bottom changes, whatever it's, because it's dependent on where it started. So the percent change, the percent that something changes, is how much it changed by divided by where it started. Because that's what it's based on, where it started. Maybe. All right. I keep doing that like I'm Dragon Ball. All right. So I'm going to give you something that's less not about money. Let's say last year my bowling average. Well, I suck at bowling. So my bowling average was 102. That's being nice, actually. I get a little better after I've had a few drinks, man. This year, let's say I got a little better. It is 110. What percentage did it change by? So this idea does not just work with money, it works with anything. So figure it out. Don't say anything out loud. While you guys do that, I'm going to pass out the practice test. Tomorrow I'm going to have the answer key for this. Because you guys remember when the test is?
Thursday.
Shit, yeah. This Thursday. This Thursday.
We're all ready.
What's up? Sorry. No. Please don't give this to me. Please don't. I'm going to give you the answers tomorrow. I don't know. So you don't have to do this at all. If you just want to focus on homework, that's a good idea. But if you happen to have time and you want to look through and make sure that this makes sense and then check it against the answer key, great. At the very least, you can see how I lay out my tests and kind of what the problems sound like. You know what I mean? Because a lot of you guys have never taken a test from me before. Some of you guys have. All right, so help me out here. How do I figure out the percent?
So, change was 8,
Yeah, changed by 8. Is that cool?
right?
Changed by 8
Over the original, which was 102,
over the 102.
which equals point.
Oh, I'm sorry. What's it look like? Oh, of course, that makes sense.
0.0784.
Thankfully, I don't handwrite my own tests. I would so suck. I put them on the ditto machine. You guys are way too young to
I
even
know
know
what
what a
that
ditto
is.
machine is.
It used to turn your hands
I used to do that in the math department. I was the guy that did the ditto machines, and then you just sniff them and get high. It was great. Here they are, man. So what's 8 divided by 102? Almost 8.
0.0784.
0.784, roughly.
There you go.
And I would tell you where to round to on the test, so you know where to have to stop.
So how did you get 8 again? So what if we?
How much did it change by? 8. It changed by 8. Divided by, why did it divided by 110? Because the original is 102. That's what everything's based off of, is what it was to begin with. So this is 7.84%. Is that cool?
Yes.
So to ask you for the percent change, you got to have the answer end up in percentage. It kind of makes sense. Okay. And there are a couple of specific examples in Appendix B. There's the commission example, but it's really the same idea. Anybody ever have a job where you work on commission? Anybody? A few of you guys? I would hate to have that job, man. That's the store you walk in and somebody comes up to you, attacks you, and they say, if you buy anything, call me over. I'm the guy, call me over. And they're trying to make their commission. So let's say I work on, I got 2% commission. Ooh. Wow. At a car dealership. That means I make 2% of the sale price of the car. That's the extra that I get on top of my regular pay. You guys understand?
Yeah.
Yeah, car dealerships are huge for this. That's why they're like, can I help you? I'm going to follow you. It's like, leave me alone. So 2% commission on a car dealership. Let's say I sell a car worth, or at, let's just say at $21,000. What will my commission be? So I'm not changing something. This is direct application of percentage. Right, direct application of percentage. This isn't anything too crazy. You just do what?
You turn the decimal into the percent into a decimal.
And then
you multiply.
multiply. So it'll be 2%. In words, it'll be 2% of 21,000. All right, we're 2. Oh my God, Jeff. It's bad for you, dude. All right. 2% of 21,000. That's how much money I'm going to make in addition to my salary. So then my commission. Commission just means the extra. It's an incentive, right? So it would be 2% is, I get 0.02 times 21,000. If you do my trick, 1, 2. 1, 2, twice 210 is 420. I didn't make it come out that way. You're wondering.
Talking about getting high and stuff. I'm just kidding.
I would never.
Yeah. You just it's working.
My dean sometimes watches my videos.
So
Is that cool? Yes.
do the decimal, you do the same thing for the number. That's
Yeah, I really, again, if this doesn't make sense, you never have to do this, right? If it doesn't make sense. But, isn't 0.02 2 out of 100?
yeah.
And so couldn't I just divide that 100 into this number instead? So the shortcut is if I move the decimal this way on one number, I move it back on the other one so that overall it's the same number.
You just wipe out
You have
the
to move
zeros.
it backwards, not.
Against the movement you made. So if I move that one that way, I got to move that one that way, so overall it's still the same.
So
That's the idea.
you can just move them to any column.
This is when I'm multiplying decimals with other numbers, right? That's when it works directly.
So you
So-
can do that, right?
Totally.
So it's kind of like whatever you do to one side.
Why do you
Sort of. But they're both in the same side, that's why you actually do the opposite. Right? All right. Okay. So that's Appendix B. At least one person's already done Appendix B, so you got to get in there and try that out. The last thing I want to talk about, we're only going to do up to 7.1. Stay with me now.
So the test tomorrow will be up to 7.
Test on Thursday will be
Thursday.
up through 7.1. Homework only up through 7.1 is due. 7.4 we do with the rest of it for the next test. Does everybody understand?
Oh, okay.
I'm not going to make you do homework on something that I didn't even talk about yet. Give me a few years, maybe I'll be that evil. Bless you. Of course, I said the same thing a few years ago, so I don't think so.
I'm over.
Now, the reason I kind of like doing 7.1 by itself because chapter 7 is all about probability. And at the heart of it, probability is all about counting. Right? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. There's 24 people in here. Right? And how many of you guys like broccoli? Anybody like broccoli? Oh my God. How many of you guys don't like broccoli? Let me do that. Okay. How many of you guys don't like raising your hand? All right. That's neat. That's a paradox. All right. How many guys are left-handed? There, ask that one. I'm sorry. I'm pointing out. You're left-handed? Damn. Great. So, the probability, if I picked one person out of this room, the probability I would pick a left-handed person would be 1 out of 24. Is that?
Yeah.
The idea of probability is based on counting the total number of things. So if I was doing a probability of picking a king out of a deck of cards, what would go on the bottom would be the number of things that could happen. How many cards could I pick? 52. There are 52 cards in a deck of cards. And how many kings are there in a deck of cards? So the probability I would pick a king would be 4 chances out of 52. So it's all based on counting. So section 7.1 just looks at different ways to count. Believe it or not. And I don't mean like 1, 2, 3, or using your toes. No. What I mean is, let's say that there were, I'm going to choose 2 pets. Right? And there's 5 dogs I can choose from. I'm going to choose a dog. And there's 7 rabbits. Rabbits are evil. Rabbits. And they could be amazing, but they could also be evil if you don't know what you're doing. So I guess that would mean they're not less evil instead of ignorant owner. But so I want to know how many different combinations of pets can I make. So there's 5 different dogs, right? And there's 7 different rabbits. So how many options are there for the dogs? 5 options. So I could do this visually. I could say, I'm going to call them, just for the sake of being able to write this down, dog A, dog B. What a great name, Jeff. I love my dog. What's his name? E. Okay, right? So I could choose any of those. If I choose dog A, how many rabbits can I choose from? 7. So that'd be 1, 2, 3, 4, 5, 6, 7. Fluffy and Peter and whatever. Right? You guys kind of with me? In fact, I would have this off of each one of these, right? So for every one of these, every dog I could pick, there are 7 rabbits I could pick. So how many total am I going to end up with at the end? 35. It's times. For every one of these, for every dog, I can pick 5 different dogs. For each one of those, there's 7 different rabbits. So if I said there are 5 crates on the ground, and each crate there's 7 grapefruit, how many total grapefruit are there? 30 freaking 5. It's a definition of multiplication, right? So there's 5 different dogs. For each one of those, there are 7 different rabbits. 5 times 7. There's a total of 35 different combinations I could make. Just do know. Okay. So say I want to pick a car. I can pick a red, green, or black car. And I can pick a 2-door or a 4-door. And I can pick, what you got, Jeff? Give me some more options. What else you want?
Minivan.
Convertible or
It's either not convertible.
Say again?
It's either not.
Oh, okay.
Oh,
I can pick it tinted,
Or
not tinted, or just the front tinted. Are you guys with me? Real quick thing, when we moved to Virginia, my car had tinted windows, and I was driving through there, and I got a ticket for the damn thing, because they didn't have the right state-approved tinting on it. So I had to scrape the shit off. That was awesome. Scrape it off. That was, anyway. So do you see there's 3 choices I need to make? Here there were just 2 choices. That's why there's 1, 2 spots. So here how many spots am I going to have in my little hangman game? 1, 2, 3. How many options for the first thing? 3. Deux. 3. Okay, so for every one of these, there's 2 of these, and for every grouping of those, there's 3 of these. That's why it's the counting. It's called the fundamental counting principle. You take number of options times number of options times number of options for however many things you're going to pick from. Yeah, so you get 18. Cool. All right, how about this? Let's get even more specific. Pick a password for some place, and they have, sometimes they have these stupid rules. It's got to have at least 1 number, and it's got to have a special character, and you're like, oh, God.
One has to be capitalized.
One has to be capitalized at least, and blah blah blah. So let's make some weird rules here. Pick a password. 7 characters. Thank you. That's a good word. Where the first 2 are numbers, right? The last 5 are letters, but the last letter
Must be capitalized.
can't be a B. All right. Let me let that sink in. All right, because they had some issue with the last letter being a B. I don't know.
his girlfriend's last name started with
Exactly. Whoever the IT guy is, he's like, screw you, Brenda. All right. So help me out here. How many places am I going to have?
on the
7.
keyboard.
7. 7 places, right? Now, the number of numbers and the number of letters is going to go into each place, because that's how many options for each thing I got to choose. But how many things must I choose? 7 characters. I like it. So choices for the first character, second, third, fourth, fifth, sixth, seventh. How many choices do I have for the first 2?
0 to 9.
So how many is that?
10.
There are 9 options.
10.
Or because
1 divided by 9? 0. Right, so there's 10. 10 options there. And of course the second one, another 10. Is everybody cool with that so far?
Yep.
Now the last 5 are letters. So for almost each of these, how many letters, of course, are there in our alphabet? It can be some Russian stuff, all right? 26. 26. Now what's the only one that's going to be different? The last one's going to be 25. I like it. Now try to multiply that out in your calculator. See how many possible options for passwords there are following these rules.
It's a lot.
A lot is true. But what's a little more specifically?
1, 4, 2.
Wait. So 1,
1, 4, 2, 4, 4, and then 0.
1, 1, 4, 2, 4.
0, 0,
1, 1, 4, 2, 4.
And then there's
Another 4.
And then 0.
And then 4 zeros. Okay. Swoop, swoop, swoop. So what is that? Thousands.
You got options.
Thousands.
Million.
Millions.
Million.
Billion.
Billions. I like it. So that's in the billions. So this is kind of the work you would do. I don't know if you ever heard about the total number of pizza combinations you can make, and it's in the 100 millions. And it's not something that humans can immediately understand all the different possible combinations of things. Right? It's always more than we think. Cool. There's not quite enough people to do something that I always love to do. Because I don't think I've done this with you guys, where I say, what's the probability that somebody in the classroom has the same birthday as somebody else?
No, we haven't.
Do you think that's a high chance?
No.
Yes. If there were like about 30 or more people in here, then I'd feel pretty good about my chances. It'd be more than 50% chance. And the reason that it doesn't feel like that would be true is, number one, you think about yourself first, which is, biologically true. Think about yourself first. They're like, nobody else has my birthday. That's crazy. But it's any two people in this room. So how many pairs of people are there in this room? A lot more than you think. Because I compare you with everybody. And then I compare you with everybody. And I compare you with everybody. Holy shit, that's a lot already. And I'm not done yet. You guys understand? So I used to, I don't know if you want to try this. I don't think there's enough people here, but we can try it. Where are my January babies? January babies? Anybody? All right, we can skip January. January?
No.
January. Sorry, you can't be matched with anything. What's your birthday?
Yeah.
11th. That's freaky because I was thinking 11, but I can't get your turn. February, babies? Any February? What's your birthday?
24.
28th? 20th, I was going to say. That's freaky. January, February, March. Any March babies? Birthday?
14, 12.
Damn. See? Close. April babies? Oh, that's all yours. 30th? Okay. April, January, March, April, May. Good.
5.
You guys are all distributed. I love it. March, April, May, June. Oh, wow. Okay. 18? 3rd? 23rd? 10th? April. Where am I at? March, April, May, June, July. July is all yours. 18. August.
10.
September. 21st.
14.
29.
First.
October. It's all yours. Huh? 11th. November.
23.
23. 23.
23rd.
23rd. 5th. 30th. Man, that's close. And then December. It's all yours. Okay. So normally if I have like on the first day of class, I have about like 50 some odd people in like a stats class or something. There's only one semester that it didn't happen. Because once you get about 50 people, there's about an 80% chance it's going to happen. That there's going to be a match. So I feel pretty good that there will be a match. There's only one time, and the whole time I've been doing it, there hasn't been a match. But there just weren't enough people to guarantee a match, and we didn't get a match. Anyway. So next time, tomorrow I'll have the answer key for this.